Hi, this is Victor and welcome back to my math tutoring channel. In this video, I will explain the mean value theorem, and at the end, I will illustrate a function and find the point C that would allow me to prove for you that formula here. This formula. Okay, so now to be able to have the mean value theorem, the function should be continuous in the closed interval a and b. So should be continuous on a and should be continuous on b too, and between a and b. And the function is derivable in the interval between a and b. Yeah. If it is the case, then there is a point C between a and b, such as f of b minus f of a equal the derivative of c b minus a. So now, to find that point C, the best way is to do an example. Let's take the function f of x equal x to the power of 3 minus x. I know that function is always continuous. There is no restriction. When there will be a restriction, let's say if I have square root of x plus 3 in my function, my restriction should be x greater or equal than minus 3, because otherwise my square root will become negative, and we're not doing complex number here. Square root of a negative number does not exist. It exists in the complex number, but for that course in Calculus 2, square root of a negative number does not exist. So this is one restriction. Or if I have something divided by x plus 3. So we know we cannot divide by 0, so x should be different than minus 3, so my restriction is the point minus 3. So between a and b should be always continuous. In that case, it is always continuous wherever we are. Yeah. And the second condition is that function should be derivable to the open interval a and b. So if I find the derivative of f prime of x is equal 3x squared minus 1, so it is derivable, and even whatever the a is equal, whatever b is equal. Like, what do they mean a and b? So if I want to draw that function, it should be something like that function, and this is, let's say, my a and this is my b. So it should be continuous between a and b, and it should be derivable between those 2 points a and b. So that function is derivable everywhere and it's continuous everywhere. So I can use the mean value theorem. The mean value theorem, the function, and I want to study it between a equal to 0 and b equal to 2. And b equal to 2. Yeah? So the function is f of b minus f of a equal f prime at that point C that we'll calculate right now, b minus a. In my case, my a is equal to 0 and my b is equal to 2. So f of b would become, all what I have to do is replace that x by 2, which is in that case f of 2. Let's write it f of 2 because b is equal to 2. I will replace that x by 2, that x by 2, and that x by 2 is equal 2 to the power of 3 minus 2. 2 to the power of 3 is equal to 8 minus 2 is equal to 6. And f of 0, I replace all the x's by 0. It becomes 0 minus 0, which is equal to 0. And I know f prime of x is 3x squared minus 1. So that formula, I can write it f of b, which is 6, minus f of a, which is 0, is equal f prime of x at that point C. So it is 3x squared minus 1 multiplied by b minus a. B is 2, minus a is 0, which is 2. So I have 6 equal 3x squared minus 1 times 2. I can divide here by 2 and divide here by 2. I will have 3 equal 3x squared minus 1. So that one would come here, it become 4. So 3x squared is equal to 4. That means x squared is equal 4 divided by 3. That means x is equal plus or minus square root of 4 divided by 3. But I know square root of 4 is equal to 2. So x equal plus or minus 2 divided by square root of 3. If you do 2 divided by square root of 3, at your calculation, it is plus or minus 1.15. But that point C should be between A and B. So minus 1.15 is not between 0 and 2. 1.15 is between 0 and 2. So x equal minus 1.15 to be rejected. So my C should be equal to 2 divided by square root of 3, which is equal almost to 1.15. Before I draw that function for you and explain what does it mean, where is C, if you like my video, please subscribe to my channel. That would help me tremendously. And if you like the video, if you press the like button, I would really appreciate it. So C equal 1.15, that means this is the tangent on that function. So if I want to draw that function, the function we said f of x was x to the power of 3 minus x, yeah? So if x equal to 0, y is equal to 0. If x is equal to 1, I would have 1 to the power of 3. If x equal to 1, y is equal to 1, because 1 to the power of 3 is 1, minus 1 is 0. So that's another point. So I have the point 0, 0, I have the point 1, 0. And if f is equal, we studied it, if f is equal to 2, I have the point 6. So for x equal to 2, I have, let's say this is 6 here. It's somewhere here. And if x is equal minus 2, so I would have minus 8 minus, or let's take it, if x is equal to minus 1, okay, if x is equal to 2, minus 2 is minus 8 plus 2 is 4. So if x is equal to minus 2, this is 4. It's somewhere here. And I know there is a point for x equal 1.15. If I replace, because my C is 1.15, I have to put it. If I replace x by 1.15, let's do it on the calculator. 1.15 to the power of 3 is equal 1.52 almost. Minus 1 is 0.52. So it's almost 0.5. So let's say this is 0.5 here, which is, this is 2 divided by square root of 3. So I know it should pass by that point, but it should pass by this point and this point. So I think it goes like that. And because, yeah, it is like this. So it is tangent, the mean theorem that tells me there is a tangent on that curve at that point, 1.15. So that's it for that video. Thank you for listening.